Okay, so welcome to our first live stream of live coding using WebCode and Observable notebooks. Today I'm joined by Gabriel Koch of AgroPatterns fame, and we're going to be building something together over the next few episodes about smart farms. So maybe it's better if Gabriel says what AgroPatterns does in your own words. Gabriel.
Sure, Tom. Well, thank you for having me. This is really fascinating technology for me. We have been helping farms in Colombia and Ecuador over the last 5 or 6 years, helping them introducing technology to help them optimize their processes. And by doing so, we are hoping to bring farmers closer to reducing waste, being more sustainable and hopefully helping them predict their time to market better. The flower farming industry is very sensitive to peak seasons, Mother's Day, Valentine's Day, and whatnot. So we through technology and industrial processes that are highly automated, we're helping these farmers grow their product in a much more sustainable and more industrial way.
Okay, cool. And you're one of our early pro users on WEBCODE.run. So when someone signs up for the pro account, it has a few features. So WebCode itself is adding a serverless layer to Notebook. So this allows us to use the Notebook code within larger systems because now they can speak HTTP. So the reason for using WebCode, it extends Observable and allows notebooks to have a presence on the internet. And it's free for anyone to use. In any notebook, you can bring up a WebCode endpoint, and then that endpoint is live. It will receive HTTP traffic and do interesting things. If you sign up for the Pro membership, then some of the benefits is that now you can deploy HTTP endpoints in private endpoints, and also you get lots of free support, and we can do projects together like this. So I'm just wondering what made you think how do you think WebCode can be useful in your business, and what can we do?
Okay, so let me give you a little bit of a background. And I think we have really good technology in their current version of AgroPatterns. We chose Meteor, which was, and it was a really interesting stack, 5, 6 years ago. We use React, we use React Native, we use Expo. We use really interesting technology, but at this point, I feel like I have just a grocery list of technologies in order to deploy something. So that was a concern that kind of led me to simplifying the workflow of building up our technology or the future of AgroPatterns. The second part is the integration with Observable. Our users do not sit in front of a computer all day long. They are in the field working, their greenhouses and doing all the stuff that they do, and they have to have access to the conditions of the greenhouses. But they're in the field, so just maybe a graph that shows the severity of mites in a greenhouse, for instance,
Yeah.
and of the concentration of mites in maybe 3 or 4 beds. It's critical so that they can attack that problem quickly. But they're in the field working, so we don't need a lot of dashboards. We just need hopefully graphical information quickly deployed to the people that need to make decisions. And I see that Observable provides just all the underlying technology to build these quick graphs that we're looking to implement.
Yeah, exactly. Yeah, I mean, I love Observable because it's so quick to develop with, and I love the way that everything just runs instantly and it's reactive. It's just very easy to build new features and to come back and to maintain stacks and things like that. So yeah, I'm loving it. So the aim for our prototype, for example, well, there's going to be, so let's sort of try and figure out what we're going to do in this series a little bit in more detail. So the aims for our prototypes, which we're going to do over, there'll be quite a lot to do. So we'll do this over a few sessions, and we're not aiming for a production ready thing. We're aiming for a proof of concept for a new version of aggro patterns, or something similar to what you already have in production now. But one that what the kind of things we're trying to emphasize, that it needs to work offline, because this is for agricultural workers in the field. So number one priority needs to work offline. And when we mean offline, obviously there could be a server running all the time, but we want the user's interactions to be either offline, or I think we mentioned offline messaging through WhatsApp, right?
That's correct. Yes, WhatsApp is really the universal communication tool for people around the world, I think. And maybe less so in the US, but WhatsApp is just the way people communicate.
So naively, I would think that WhatsApp needed an internet connection, but it doesn't, right? It can fall back to SMS or something.
Well, that's correct. If you have access to the cellular network, which is much more reliable than Wi-Fi, then you have access to WhatsApp, and that's a critical thing.
Yeah.
Looking at the broader picture, the cellular network in most places in the world is just very prevalent, whereas gaining access to Wi-Fi is just not a given, especially in rural areas.
Yeah. Okay. So before I've done work with WEBCODE and we integrated it with a Twitter bot. I would imagine integrating with WhatsApp. This will be, a bit of work, but it'll be relatively straightforward. There's definitely something we'll get to later. I would say that's a big chunk of work. So we'll probably dedicate a stream later to building on WhatsApp. And then, where's the data coming from?
The data currently comes from people have a phone with them,
Yeah.
and they have an app. It's just built on Expo basically, and with a very simple interface. Basically, using their thumb, they collect data associated with each flower bed. You have workers walking up and down flower beds. Think of a greenhouse as a semi-enclosed greenhouse the size of a football field, with a central path and 100 beds to one side, 100 beds to the other, and you have people walking the paths between flower beds every day of the week. And with a handheld device and their thumb, they basically move their thumb to the right or to the left to identify from 0 to 3, just a qualitative evaluation of the amount of insects or disease, such as mildew, for instance. So it's very simple. So because they have to do it quickly, they basically are allotted about less than two minutes per flower bed, and a flower bed can be 30 meters.
Okay, wow.
So they're moving fast,
Yeah.
and they have to be looking at the problems with their flowers.
Okay, 2 minutes per bed. So how do they actually? Yeah, this is interesting. So I can imagine they're at flower bed C, and there's a load of sliders for saying all these things that you want them to measure. And then how do they click onto flower bed D? Is it just go to the next flower bed? Yeah, I suppose that's just how it is.
There's a hierarchical menu.
There's an ordered set of flower beds, and you just rattle through them.
The greenhouse, and then the greenhouse is subdivided in some cases into naves. So a nave has about 10 flower beds, and then so you go nave 1 and then bed 1, and then you start the process. It's almost like moving through a labyrinth with a timer.
Yeah,
because
Well, yeah.
quite productive.
Okay, so that's very interesting. Yeah, so that, yeah, okay. Yeah, I believe WhatsApp does it have some? I think it even has some support for some UI controls, like that you're able to do sophisticated widgets, or maybe I'm thinking more of Slack, or we'll need to.
Yeah, I think that WhatsApp, the idea with the WhatsApp is even more basic than that. It's being able to query to ask the server for something very specific, and the return from the WhatsApp bot would be to just send a graph, for instance, concentration of mites, and then in greenhouse one, and you get a kind of a cell diagram of 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 the location of the greatest infestation, and that's it. That's all you need.
Oh, cool. Yeah. Okay. Yeah. Yeah. Um, should respond to queries about where infestations are, for example. And yeah, so there's manual data collection, and also is there any like automated sensor collection?
Yes, I mean, what's just as important is, and I may be getting into a little bit more agronomy than our.
It's fun. It's all interesting. I'm fascinated. Yeah, like yeah, take us on that journey. It's good.
But basically, I mean, flowers as well as insects and as well as disease grow under certain environmental conditions. Flowers thrive when they're, I'll say, between 3 degrees Celsius and 28 degrees Celsius. I mean, let's just say 35 degrees Fahrenheit and 95 or so. Below the 3 degrees Celsius, you are going to have flowers that wilt, and above 28, you're going to have flowers that just basically fall asleep. Now, every variety, and I'm going to get into the weeds here.
Yeah, literally. Yeah.
No pun intended here. But basically, if you are planning to deliver flowers for Valentine's and you have a specific variety, that variety takes a certain amount of time to mature. And in order to mature, it has to have a certain amount of what it's called growing degree days, which is the amount of time that the flower is within the permissible rate, within the growing temperature rate between 3 and 28 degrees. So let's say that you have to count, I don't know, 2,000 growing degree days or whatever the number may be. But it happens that the greenhouse heats up during the day because although these flowers are grown in Bogota and around Quito, which have very temperate climates, we all know from climate change and whatnot, the greenhouse effect, that if you have plastic overhead above, you're going to heat the greenhouse. So that means that if you have greenhouses at 35 degrees Celsius during the day, those times cannot be added to the maturity date of the flower because the flower is not growing. So that long story to basically say you need to time this properly, and in order to time the harvest properly, you need to know how many growing degrees days you've accumulated. And the only way to do it is to have an automated thermometer sensor that captures temperature and humidity inside the greenhouse. And that's what we've incorporated recently. And so that way we know every 10 minutes or so what the temperature of the greenhouse is.
Temperature and humidity. Yeah. Okay. And is that what technology is used for how does the sensors get the data?
Okay,
to
so
home base?
I mean, it's fascinating. The realm of IoT is just changing so rapidly. We've been working with technology from Blues Wireless. They created this thing called the Note Card, and the Note Card comes with just connectivity anywhere in the world via the cellular network. And we have built a solution. I may find a prototype here behind somewhere. And so here's a prototype of our device. It has a sensor here at the end, and this is important that it has a long cord because flowers have different sizes. They grow. So sometimes you want to measure the temperature at one level in the greenhouse, and some other times you want to monitor the temperature lower because you just have the little seedlings. So we hang these sensors from a post inside the greenhouse, and they start sending information immediately. They connect to the wireless network.
Oh, these are cellular as well. Yeah.
Those are cellular. It's important to know, and I don't know if your clients devote a lot of time to you when you're implementing a project, but we cannot afford. They do not give us the time of the day. They are too busy producing their flowers. So we just have to, things have to work in the field immediately.
Yeah.
And that applies not only to the sensors, but also to our app. Has to be really simple to use because we can't afford to train them for more than, literally a couple hours and so on. So these are the challenges, and getting back to your question, we built our technology on Blues Wireless and other components, Arduino and whatnot. But this is the way we've proceeded.
Yeah, I've just got the Blues Wireless website up here. So so you can attach all these different sensors, and it goes to some card. And then there's a Note Hub. Is that a different piece of hardware, the Note Hub? Or is that...
The Note Hub is actually not hardware. The Note Hub is software.
Okay, so that's like a SaaS somewhere.
That's
supplied by Blues, right?
That's correct.
Yeah, and then they show on their diagram that you can get that data out and send it to Azure, AWS, or custom. So in our case, we would like this data. This is great because, all this data collection is done for you, and as you say, over the cellular network, so no Wi-Fi setup or anything. It's just works, and it even collects all the data, and then it gives you these different routes to export it. So I think what we'll be doing, probably not this episode, but we could definitely prototype exporting this Note Hub to I guess a custom integration. We'll cover this in more details later, but that's very interesting. So this is important data, and that's the temperature and humidity. And ultimately, so by tracking these, you'll have a guess of when the flower's going to mature. And then if you've got some business need for it to mature at a certain point, what then? What can you do?
Right. Well, I mean, I don't know how many golfers there will be watching this episode, but the Masters always has their azaleas blooming at the right time. But what people don't know is that if the azaleas are behind schedule, they put lamps. The people at the golf tournament put the lamps on top of the azaleas so they bloom faster. And if they're blooming a little too fast, they put a bunch of ice on top of them, so they affect their growth.
Wow.
So that's kind of what people see on TV sometimes. But let me talk about the third part of this triangle, which is what is commonly known as countermeasures. Countermeasures are really what the farmers use to attack pest and disease, being chemicals or, in some cases, just natural ingredients. But this industry uses a lot of chemicals, and chemicals have active ingredients, and the active ingredients are also susceptible to temperature ranges. And so that translates basically that, if you apply chemicals that are, as we all know, are getting more and more expensive by the day, if you apply them at the wrong temperature, they're basically worthless.
Yeah.
And they obviously affect not only, the bottom line, but, you create a lot more toxicity inside the greenhouse than is needed, especially if it's not going to help with your infestations.
Okay, yeah, so you've got quite a complicated, the farmers have a complicated optimization problem to do. They've got, yeah, they can control temperature, they can apply countermeasures, they've got business targets, their plants are all growing at, the way they do, and then, yeah, they've got to figure out what the best thing to do is.
And to your point, Tom, the problem is that there's a lot of waste in this industry because they cannot do it.
Yeah.
And you really do need to automate some of these pieces in order to reduce waste. I mean, when you just have no insight into either the temperature of the greenhouse or the amount of chemicals applied or the severity of an issue, then you overcompensate. You you do a blanket spray for the greenhouse instead of targeted sprays. You plant more than you need to. You eradicate more plants than you need to, et cetera, et cetera.
Okay, well, that's really fascinating overview of what happens on a farm. I didn't know all this stuff. It's really interesting. For our prototype, a bit more concretely, so let's just enumerate what we know. We want it to talk over WhatsApp at some point. So this would be something worth prototyping. How do we get data in and out of WhatsApp for some kind of like centralized? Right, okay, let's rewind, follow the journey of the data. So there's some automated data coming out of the sensors, and we need to export that into some decision-making system. So step one would be, how do we integrate with the Blues Note Hub? That has to be maybe stored in some central place so that we can make decisions on it, because it's not just the sensor data we're making decisions on. There's also potentially manual data coming in. So there's going to be data coming in from a variety of different sources. It's not all covered by just the Blues sensor. So data's coming in. We want to centralize it perhaps, and then make decisions on it. And then those decisions need to be forwarded to workers who are using WhatsApp.
That's a valid statement, and then it's not only exclusively WhatsApp. There's a lot of people out in the field, but there's also people in front of a computer that can see the trends. I mean, the production manager has to see all the greenhouses.
Yeah, okay, so a different set of people need different views on the data. So that definitely means that we probably want to centralize the data, and then there's going to be a variety of notification mechanisms and also dashboarding and whatnot. Dashboarding, bread and butter of Observable, and then notifications and interaction with the Note Hub. This is where you need a system that can speak HTTP. So this is where WEBCODE would provide that bridge between Observable notebooks and other third-party systems, WhatsApp or Blues Wireless, whatever.
Right.
So that's like a sketch. I'd try and draw it, only I'm really slow at drawing things on the computer. For this episode, I think maybe let's just start by trying to set up a central place for our storage. Yeah. Okay. So this episode, let's say, right, aims for this episode, centralize storage into a notebook, and what we want is a single place where we can see our. Maybe we'll call this notebook like our data warehouse, the central place where all the data is going to be, and we'll be in charge of owning the data, and maybe we can put a few dashboards off it so that we can see that we've actually got data. Okay.
Mm-hmm.
Okay. So with Observable, it's a front end technology. So if you want to do data, you need a database that is friendly with front-end stacks, which unfortunately is not things like Postgres. We can use, there's a few different options. I think you already said you use Meteor. Meteor's one, or also Firebase, which I have a lot of experience with. and is what I've been using on Observable. Some people are a little skeptical of using Firebase, especially Europeans, where they're worried about GDPR and data sovereignty, and they don't want to take a dependency on Google. I've been listening to this, and most of Firebase is open source. The only bit that's not open source is the server. So what I've been working on, I'll put a link to it here. I've been trying to build a Firebase compatible server. So you can still use Firebase, the clients, but instead of them connecting to the Google servers, they'll connect via WEBCODE to anywhere you want. You have to supply a Redis backend, but you'll be able to use Firebase but store your data on your own premises. So, but it's not ready yet. So for now, we'll just use Googleified Firebase, and then maybe. Yeah.
And actually, I'd like to say that when you mentioned Meteor, actually, I mean, it's obviously it's Meteor, but Meteor connects to MongoDB, which is. But yeah, let's go with Firebase.
All right. So I'll just leave a link in here in case you want to read about that. So we will use Firebase for now, and I have a notebook. Let's look this up. So this notebook gives you the instructions for getting started with Firebase. And the link I just went to. So this helps get started with Firebase on Observable. The first thing we need is a project. So we might as well just go through the whole process. That's probably going to log me into my one. Is that safe? Yeah, no, that's fine. So let's create a new project. What should we call this?
Why don't we call it AgroPatterns IoT?
AgroPatterns IoT. Patterns. Go ahead, don't make a mistake here, because there's no going back from this one.
Well, dash maybe between the S and the IoT would be good.
Are we allowed a dash? Yes, we are allowed a dash. Okay.
Okay, good.
Okay. Google Analytics. No, this is like borderline Trojan horse, right? Create project. Okay, this is takes a little while provisioning these projects, but you only have to do it once. And so with Firebase, there's a few database options. Like there's the real-time database, which is their original one, and then there's the Firestore database, which is the more modern one. The one I want to try and make an open source version is the older one. So therefore, we're going to build on the older one now, the real-time database, which has slightly less querying capabilities, but it's actually faster.
Let me ask you. Let me change the subject here on you. Our need is not only getting the data in, but also aggregation. So at some point, I would like for you to talk about aggregating data, right? So you may want to you capture data at a certain level of detail, and at some point you need to aggregate it to. And I'm sorry for changing the flow of this, but at some point it's not only there's a further need of the data stream.
Yeah, let's make a note of that. Yeah, this is going to be So we need to centralize storage into a notebook. Let's use Firebase for storage now. Later we will need to aggregate. This is not completely straightforward, but it's not. Yeah, we'll get to that. Let's see if we might even get to that this episode. What's the time now? We've got 30 minutes left. Yeah, we'll try it. We'll see if we can get that far. Where do we want our data? Well, I suppose the United States then.
I think so. Colombia and Ecuador are United States Central right now.
Yeah, this is like a limitation of this real-time database. You don't have many options where your data goes. So, you know, when we have an open source version, you'll be able to put the database like right in your house if you want and have it absurdly fast. Start in locked mode, start in test mode. Yeah, let's do test mode. What that does is unlock the database so there's no security. We'll change that fairly quickly. So that's created a project with a database. Next thing we need is we need to create. Say it's going to have a web presence. We'll call this the warehouse. Don't set up Firebase hosting. No, just create. We have to register this app. I don't know what this is for. This is so it has a API key. Right. This is the magic bit. This is the config for the Firebase. I'm not used to this. Firebase config equals, and that doesn't work. Right, there we go. And we don't need Messenger. We don't need a storage bucket. We do need a database URL. We probably will need an auth domain. We do need an API key, and we do need an app ID. Yeah. So that's like that tells the observable environment which database we're using. So this is how we're connecting Firebase to Observable. What else do we need? Sorry, then backend. So this tells you how to set it up. So we've done the Firebase config bit, and then we have to just import the library. Yeah. And now, so if we create user, we might get a login form. We don't get a login form yet because we've not turned on the login options. Oops. Yeah, what we can do, maybe this is a good idea. So this is in the instructions of the main Firebase thing. In addition to the Firebase config, you also create the Firebase UI config, which is about the login options that we are going to offer. Let's just, for now, because let's allow anonymous login. And then hopefully this should, maybe this will refresh. Let me just refresh it. Oh, I know why this is wrong. This is view of user. Sorry, this one should also be a view of user. There we are, continue as guest. Okay, so now we can do anonymous login. This is not super relevant quite yet. I'm maybe jumping ahead of things. But anyway, the point is we've now got a Firebase database set up. Right, what we want to do is read and write data to this centralized storage. So if we go back to our real-time database, this is our console. And our data is exactly null at the moment. There's nothing in it. And what we want to do is write some data. So how do we write data? This is about login. That's about login. This is about listening. Tests. Let's got some tests here. Oh, if we grab Firebase/Firestore, so we're not using Firestore. So our database is now, let's mark these up properly. So this is, let's call it the database. And our database, we'll call it DB equals Firebase. Firebase is an SDK with lots of different things. One of the things being, and I think that's a function, one of them being the real-time database. So that says, that's putting the database SDK there. So now we've got a database reference. So this would be the order you do it. You import it, you've got the database. Now let's, you have to form a ref. So at a position in the document tree, so we would go like sensors, S1, sensor1 is a ref, but we want to write data to it. So set, actually sensor1, actually it would be a timestamp, wouldn't it? Well, we'll just have a look at how this works first. So sensor1, and we'll set its value to be, I don't know what kind of payloads these do. Value.
I mean, you definitely have a timestamp as a. You also have the name of the farm, the location, the latitude, longitude would be good to have, and the timestamp and the temperature and humidity settings or values, as well as the battery charge. That's basically it.
Battery 0.5, temperature, and the time. Well, we'll just do it this way for now. Is that right? I'm terrible at programming. I forget what the words are. Okay, that would give us a weird number, which would be good. Location. I don't know what that long looks like. There we go.
I can tell you, longitude would be minus 76.5, let's say.
Minus 76 point what? 5?
5, let's see, for the longitude, and for the latitude we can say 4.7. That will give us, and that's, yeah, they're two separate values, right?
So if I execute this, after fixing all the syntax errors, so that's done, and if we look in our database now, we can see that data got placed there. What I love about Firebase is this is like real time. I guess this won't impress you because you're already a Meteor fan, but
I'm a Firebase and a WEBCODE fan now.
Yeah. So if I change that to 29 and hit enter an observable, bing, this is real time, right? So that's quite cool. So let me put that back. So you get this, so that's how we write data. Let's just make a note of this. Writing data. And ultimately, for this one, this would be replaced by Blues. Blues Wireless would be sending us these things. I wonder, yeah, okay. Yeah, there's a little design constraint. Maybe we want to be like do we just want to be saving the latest temperature to make decisions, or do we want to be recording some kind of like time series of historical as well, or do we want both?
We need both, and the reason being that we want to accumulate growing degree days, right? We want to make sure that the greenhouse is always within the permissible temperature range.
Yeah.
So that's time data, because it should send an alert if it's so that you can open up the curtains or the vents or whatever needs to be done. But also you need to accumulate growing degree days over time since you plant since you plant until you harvest.
Okay. Yeah. Okay. So. Okay. So we want both, right? Yeah, that would be interesting because then we get to treat both these things separately. So this is the basic mechanism of saving data, but like this is too simple for us. So writing sensor data. What we want to do is have like a history and a current. So I think you can do that in one go. Right. Let's start turning this into a UI just so we can start playing with it easier. So Observable has these inputs already specified. So the first thing we need to know is the name. Is that it? Inputs.text. And then we can put placeholder, not placeholder. The label is name. Yeah, okay. And this is a view of sensor name equals. So that's one of our inputs, and the other important one is the let's say temperature. We'll just
we can use temperature for now, which is the most critical variable.
Yeah, temperature is a range from -10. Do you do Celsius or Fahrenheit? I'm interested.
At Celsius and
in proper context, in working context, yes.
Yeah.
not beers on a Friday. Yeah, there we go. So hopefully that covers your temperature range. So we have the temperature. Let's sensor temperature. Let's do this properly. Oh, and we want that labeled as well, so it looks nice. Temperature. Cool. And then we want a button to say let's upload some data. So we'll have a button and add upload data. And what we want is when that button's pressed, we use this reducer function. So I'll just show you how that works. So this reduce function, if I open up the JavaScript debugger and look at the console, when I press that, it just executes what's in there. So it said call 3 times. But we don't want it to do that. We want it to actually upload data. Rather than, copy and paste code in there, I'll say upload sensor. We'll call that function, which is not defined yet. I'm working on it. Upload sensor. Okay, so when that sensor's called, when the upload sensor's called, we'll basically do this. But this sensor 1 becomes the sensor name. So we can do it like that. And the temperature becomes this. Temperature is that. And it will still stamp it as now. And yeah, we'll ignore the other ones for now. So, and we can give this a default value so I don't have to keep typing it. Value is default sensor name. So if I go upload data, default sensor name, I just uploaded temperature of 4.3. Actually, I don't like these when they have too many decimal points. So let's put step of 0.1. Now this will be clipped to just 1 decimal point. I'm in Berlin, so German language uses commas, which is a bit weird, I find. So yeah,
and so does
yeah, you guys do as well. Yes, I was surprised that was a thing, but there you go. That's just where I've lived. 34.1. Yeah, so this is updating, but it keeps overwriting the previous value. So what we want really is, let's say, a set of data for the current stuff, and then we also want the historical. Let's just say history. I have a tendency to overcomplicate words, right? History, sensors, that one. So now I'll upload both of them. Let's extract this time as that. So the timestamp is that. So they'll both upload the same time. This one will keep being overwritten because it's right into the same location. But with this one, we will write to a different timestamp, which will be like monotonically increasing, I think. Will it be? It will be enough for 1,000 years or so. So let's try it. So now when we upload, let's put a new number. Oh, actually we can close that. I think we're done with Firebase. We understand that. So let's do, what's good is you can set these manually as well. 0 and the current temperature, because this is a new time we've used it. The current temperature is now 0. The history is, and there's been a couple uploaded. Oh, the old one was 34. The new one is 0. So that's cool.
So,
yep.
So let me interrupt you here because you've done some wonderful things, and I've just been a bystander. You're hitting the goals, and I'm just watching. You were able to create a collection, the sensor history, from Observable, correct?
Yes.
Which is wonderful, not having to define your database in one tool or on the console and testing it somewhere else. I can see myself creating collections and I'm using Mongo terminology. I hope that's the same in Firebase. But I'm what I see here, and I'm a hack. I create prototypes in Observable, and I let our development team put these things in production. But I can see myself creating snippets of code that add data, and then I can display the data very quickly. So now I can create a line graph, for instance, of historical data of temperature.
Yes.
So that's where I see. I mean, I'm immediately as a user, I can see a huge benefit already. In whatever 30 minutes or so, you have created a database. You added data to the data, and then I can just jump in and try to create a line graph with an observable plot.
Yeah, exactly. But let's well, exactly. So we should try and do that actually. This is what's interesting about the real-time database is really they say it's just one big giant JSON, and we can index into any position in that JSON and just write data, and it will create the supporting structure as needed. So it's a NoSQL database. You don't need to define what collections you have up front. You can just write into whatever and it generates it automatically. Which makes it very quick to start. You do have to be a little careful because you end up generating garbage. So this little tree here, we've moved on from this, but this is not too hard. We can tidy that up. So we'll delete that. This is our schema going forward. We've got a history. Maybe even this sensors bit here, that's a bit pointless, but for a given sensor, we could definitely query for a given sensor the history of it. Let's see what happens when we do a different sensor name. So sensor 2 is 0, then it goes 19, and then it goes 32, and then it goes 16, and then it goes 10. Right, hopefully that's worked. Yeah, so
I can replace one of my sensors with
yeah, there we go. So sensor 2, that's what it did. And now let's try and actually, as you say, let's try and plot that. We'll leave that open there. So this is writing sensor data, and now the next thing is reading data. And it's all done by these refs still. So there's different ways we can do it. Let's do it. Let's do it the simple way first. So I'll call this a static query where we're just gonna request. So first we need a reference to what we want to look at. And we'll just reuse this sensor name. So actually, maybe that's not a good idea. Let's copy that. Static query name sensor to query sensor name. Right, and then so once we've got a reference to it, we can call, I think it's once value, is it? What does this do? Oh yeah, that's return something. Const result equals no, sorry, result. Can we what? So what I do when I get confused, this is this garbage here is the SDK has been minimized, so it kind of returns all this nonsense, and you can see, look, here's the actual real API hidden down here. So we can go to JSON. Maybe that kind of sounds useful. What happens then? Yeah, then we've got two objects. Yeah, there we go. So really what we want to do is just await that. There we go. Yeah. So I don't know if that's the most obvious way of doing it. Like you can start off with this this ref. I mean, it's all in the Firebase reading data real-time database. Maybe we should put a link to read and write data on Android on the web. So this is very useful. So basic write operations is what we did, the set. They're using the version 9. The one on Firebase is version 8. Firebase database ref blah set blah reading data. There's a simple one. There's either the streaming view where as new data is added, well, we'll get to that. This is a one-off query. And then there's another way of doing it. So this is a static query. Let's move that off. Sensor query, static query. That's that. And then we've got the other type is a streaming query. And to do one of those, we go db.reference, and then instead of once, we say on value, then we supply a callback, and this function will be called every time new data comes in, and it will be passed in a snapshot, and this is just here the reference on value. It gets a snapshot, and then the data is in that snapshot. So what do they go? They do it like this in their documentation. So data, and then we can console.log that data. And then we open the console and see what happens when this is executed. So we're going to get a snapshot and print the data. And what it's done is printed it as a collection. So it's got everything. It's got all the values from the history at that time. And now what happens if we upload another data? If I upload data, you see it prints again. So this is always updating, but it doesn't, because it's sort of trapped in this callback, it's difficult for Observable to see it. So Observable has this helpful function called generators.observe, which allows us to send the data sort of back up to the cell. So when we do it like that, we've got the data, right, of our history. And then when we upload it to 5, see, this has now got 4 elements, and that 5 just come in. So this one's real time, whereas this one is still pointing to the one we had first time. You see the difference there?
This is fantastic. Even though I'm catching about 20% of what you're doing, but but I can now see myself reading this data that you added and just trying my the graphs that my clients need.
Yeah, exactly. But this is one issue with this is it's only it can only attach to a single sensor. Well, maybe that's not such a big issue. But anyway, let's plug on. So we've got this live view, and now what would be nice is what we were trying to do. We wanted to do a dashboard of the temperature over time, right? So observable. Do they still have snippets, or did they change that?
How about a line chart?
Yeah, exactly. They used to have these snippets here, but they just changed it.
You now have them on
Yeah,
the
I'd
drop
have to
down.
do it here. So, and now I think I can query this as well. So we want to do a line chart. Ah, yeah, here we go. Values over time as a line, plot. The marks are our data is the live view. The X is, what is X? Well, the X is
The time, probably.
Oh yeah, we've got time. Yeah, X is time, and the Y is temp.
It's temperature, yeah.
Why is that not
You probably have to
Is it?
navigate the. Is it response?
Oh, I know why. Oh, this is interesting. No, it's because this is an object rather than. Yeah, what this has done. Yeah, the problem is this is the way Firebase works is if we look at it, it's a tree of dictionaries. So sensor 2 is a dictionary. This is a indexed by the timestamp, so it forms a dictionary. Whereas plot is designed to work off arrays. So what we've got to do is convert this into an array. So if you look at what live view is, oh sorry, not that. Oh, I'm in the wrong type of cell here. Yeah, so live view is it's an object. So 2 entries. I know, how do we do this? Object dot 2 entries. If I just execute that. Oh no, it's just entries, right, that's it. So that converts it to an array of keys and values. So now, so the entries of that object, there's 4 entries to it, and each entry is the key and the value, so the number and then the actual object. Because we've already got this number is repeated here, we don't really care for that bit. So we can take that array, we take that array of, and really I find it easy to put it as kv. So what's going to be passed into the mapping function is the kv. That's the k, that's the v. We only care about the v bit. So we'll turn that array of 4 elements of arrays into just a flat array of 4 elements. So now it's an array of 4 things, and this is so what I tend to do is call that one the raw one now. So that's come out the database, and then that requires that. And now the real data we want to work with is the live view. Okay, there we go. So that was the issue. It just wasn't. Firebase tends to work in dictionaries, and plot works in arrays. Both reasonable for the problems they solve. And there we go. Yeah. So this is the temperature did over time. What's cool about this? Let's move it up the top. So this is our dashboarding section. This will be live updated. So the last one was 5, and now we can go up. Whoa!
There you go.
and this is all, this is persisted on here. So,
Wow.
and it's exactly an hour. So I would say that's probably a good time to call it a day.
Tom, this is fantastic. This is what I have read. I haven't understood it. I've understood about 25% of what you've shown us, but now I understand a lot more. But this is exactly how I can see increasing speed of development.
Yeah.
The equivalent of a stack that I don't have much trouble with would have taken me a whole day to do this.
Yeah. Yeah. I mean, I love Observable. You can try things and it gives you an answer, or it tells you you've typed it wrong. That there's this incredibly fast feedback loop in the notebook environment, and then this is compounded by picking a database which also is all about low latency real-time feedback as well. These two things go together so well, and yeah, so we end up with these real-time dashboards without really trying. There's some things we could improve upon, right? So this query here is going to retrieve all history for all time. So let's fix that, because this is going to be a problem long term. Working with lists of data, is it in there? Is there a query? Oh, is it order? Oops. Order. How query is ordered? Limit. Well, what we can do is, so at the moment we've got 1, 2, 3, 4, 5, 6, 7, 8 things coming out. What we can do is go, before we query it, go limit to last 5, can we? Yeah, there we go. And is this the latest ones? If I limit to the last 3, yeah, no, it's truncated our recent ones, I think. Is it? Which ones is it? It's either limit to last or limit to first. Anyway, so that's how we filter it. We can add filters to it, and that prevents, when this sensor's been running for years, we don't want years of data coming back. We just want the recent data. Anyway, sorry. Yeah, that fixes that. That's a better place to finish.
No, I think it's fascinating, Tom. You've done most of the talking and all the work, but I can definitely see a completely different paradigm for developing software with this.
Yeah, so this gives us a very basic insight into how we can store data. We can store it in Firebase and retrieve it, and this will give us our dashboard and view of our various different sensors and whatnot. And then maybe what we do next week, if you're up for it, is we can actually integrate the blue sensor, so we can start reading real data into this automatically. Because we want to connect this to a real thing, and then maybe the following live stream, if we've got enough time, would be trying to make decisions on this data and alerting someone that something's happened through WhatsApp. So the next ones will be more web code focused, so we can do the integration pieces. But this is like the storage, and gives you how you visualize it and the very basics. And this is a good place to start building upon, I think.
Fantastic.
Thank you so much for your support. Thank you for being here.
No, you're very welcome. Thank you. This is great.
Okay, and everyone who's listening, thanks for listening, and listen to more. I found it very interesting hearing about agriculture, and we'll be doing more of this very soon, so stay tuned.
Do we have any chats or no? Do we have any questions?
No, there's no questions. I'm just going to hit the stop streaming button now. But you can stay on the line. We can talk on Skype afterwards. But yeah, okay. Bye, everyone.